A material that conducts electricity under certain conditions, it has properties of both metals and nonmetals. Semiconductor. A semiconductor is a substance that can control electrical currents, making it crucial for electronic devices like computers and smartphones. Imagine trying to decide whether to wear a jacket when the weather is unpredictable. Sometimes it's warm and sometimes it's cool. This is similar to how a semiconductor behaves, as it can conduct electricity like a metal when conditions are right, just like wearing a jacket when it's cold, but resist electricity like a nonmetal under different conditions, like not wearing a jacket when it's warm. Just like you assess the weather to decide on wearing a jacket, semiconductors assess their environment, such as temperature or voltage, to determine whether they should conduct electricity or not, balancing between the properties of metals and nonmetals. The adding of impurities to a semiconductor to increase its conductivity is called doping. In simple terms, doping is the process of altering a material to improve its ability to conduct electricity. Imagine you're hosting a party and your guests aren't dancing because the music is too soft. To get everyone moving, you turn up the volume and add some vibrant beats. This is similar to doping in semiconductors, where adding impurities energizes the material's ability to conduct electricity, much like turning up the music energizes the party atmosphere. Just as the new beats increase the energy and movement on the dance floor, the impurities added to the semiconductor increase the movement of electrons, thus enhancing its overall conductivity. An electronic component that conducts current in only one direction. Diode. A diode is like a one-way valve for electric current, allowing electricity to flow through it in only one direction. Imagine trying to walk through a revolving door that only allows you to enter the building, but not exit through the same side. Just like this door, a diode is an electronic component that only allows electrical current to flow in one direction, preventing it from going back the other way. The revolving door acts as a barrier that controls the flow of people, much like how a diode regulates the direction of current flow in a circuit, ensuring it only moves forward, much like how you can only move into the building through the revolving door. An electronic component that can amplify a signal or switch a current on. Transistor. A transistor is a tiny device used in electronics to control the flow of electricity, like a gatekeeper for electric signals. Imagine you're trying to get your friend's attention in a noisy room by waving your hands. Just as waving helps amplify your presence so your friend can notice you amidst the noise, a transistor amplifies an electronic signal so it stands out amidst other signals. In this analogy, your waving hands are like the transistor. The background noise is the circuit's background activity, and your friend noticing you is akin to the transistor amplifying and making the signal clear or switching it on, enabling communication. A circuit with thousands of diodes, transistors, and resistors on one silicon chip. Integrated circuit. An integrated circuit is a tiny electronic device that combines many small components on a single chip to perform complex tasks efficiently. Imagine trying to organize a massive closet where you have clothes, shoes, and accessories all mixed together. Just like each item in your closet has a specific place and purpose to keep everything tidy and functional. An integrated circuit organizes thousands of tiny components like diodes, transistors, and resistors on a single silicon chip to work harmoniously. Each component in the circuit, much like each item in your closet, has a specific role that contributes to the overall function, ensuring that electronic devices operate efficiently and effectively. A varying electric current that represents information. Signal. In science, a signal is a way to transmit information from one place to another, often using waves or electrical impulses. Imagine trying to adjust the volume on your TV remote to find the perfect sound level that suits everyone in the room. This process is similar to a varying electric current that represents information, because just as you adjust the volume to convey the optimal level of sound, a varying electric current changes to represent different pieces of information. In this analogy, the remote control's volume adjustment is like the electric current varying its intensity. And just as it communicates the right sound level to your ears, the electric current conveys the necessary information to an electronic device. A continuous signal whose properties, like amplitude and frequency, vary smoothly. Analog signal. An analog signal is a type of signal that varies continuously over time, like the sound waves of music. Think about trying to adjust the water temperature in your shower to find that perfect balance between too hot and too cold. Just like the gradual change in water temperature as you turn the knob, an analog signal varies smoothly in its properties, such as amplitude and frequency. The continuous adjustment of the shower temperature parallels how an analog signal flows seamlessly, without abrupt changes, ensuring a fluid transition, much like the smooth shift in a signal's wave pattern. A series of electrical pulses that represents the digits of binary numbers. Digital signal. A digital signal is a type of signal that uses binary numbers 0s and 1s to represent information. Imagine you're trying to communicate with a friend across a noisy room by using a flashlight to signal a series of on and off blinks that represent a secret code you both know. This is similar to how digital signals work, where electrical pulses switch on and off to convey information using binary numbers. Just as each blink of your flashlight represents a piece of the message, each electrical pulse in a digital signal represents a binary digit, either 0 or 1. Allowing complex information to be communicated clearly despite potential noise. An electronic device that stores, retrieves, and calculates data. Computer. A computer is a machine that processes information to help us solve problems and perform tasks. Imagine trying to organize your kitchen pantry, where you need to store various ingredients, find them quickly when needed, and sometimes combine them to create a meal. A computer functions in a similar way, as it must store different types of data, retrieve specific information when requested, and perform calculations to process this data, much like combining ingredients to make a dish. Just as you have designated shelves for storing items, a system for quick retrieval, and recipes for combining ingredients, a computer uses its storage for data, algorithms to access it efficiently, and processors to perform calculations, helping you manage and utilize your digital pantry. The physical components of a computer, like the CPU and memory storage devices. Computer hardware. Computer hardware refers to the tangible parts of a computer that you can touch, like the processor and storage. Imagine trying to cook a complex meal in a tiny, cluttered kitchen. Just like how you need ample counter space, a good stove, and a well-organized pantry to efficiently prepare your dishes. A computer needs physical components, such as the CPU and memory storage devices, to function effectively. The CPU acts as the stove that processes and cooks the data, while the memory storage devices are like the pantry and fridge, holding all the ingredients and recipes you need for your tasks. A set of instructions that tells a computer what to do. Software. It is like a brain for computers, telling them how to operate and perform tasks. Imagine trying to cook a new recipe without any instructions. It can be confusing and lead to a lot of trial and error. Just like how a detailed recipe guides you step by step to create a dish, software provides a computer with a set of instructions to perform specific tasks. In this analogy, the recipe represents the software, the steps are the code or commands, and the final dish is the outcome or result from running the software on a computer.